Okay, we're looking at factoring today, and specifically we're just going to look at factoring greatest common factors today. Just the idea of factoring, guys, is just undistributing. So, for example, if I had like 3, let's say here we had 3x and then x plus 1. When I distribute this, I'm going to multiply that and get 3x squared plus 3x. Factoring is undoing that and putting it back in this form up top right here. That's what I'm going to try and do. So I'm going to start with something like 3x squared plus 3, and I'm going to end up with this 3x parentheses x plus 1. So if you notice down here, I've got 4 different examples here. What we need to do is we need to create factor trees and look at, see what we have in common. And we're going to do this both with numbers and variables. So I look at 5. The only thing that goes into 5 is 5 and 1. So I'm just going to put 5, and then m is m and m. Okay, so that would be from my 5m squared. Then I move to my next term, the 45. I have 5 and 9, and then 3 and 3, and then I have this m as well. So for that one, I've got, again, if I circle my prime values, I've got this 5. Well, I won't circle them. That might confuse you here. So let's go. We'll go underline them here. So I've got those 3 things there. For this one, I've got these 4 items. And then for 40, if we go to 40, what goes into 40? I've got 4 and 10. I've got 2 and 2 for 4, and then 2 and 5. And then there's no variable as well for that. So I've got these 4 things for that. So to identify my greatest common factor, I just am going to circle what they have in common. They all have a 5. So I'm just going to take those 5s. And that is all that they have. So this 5 that I circled, that's what goes on the outside, kind of like this 3x here. So when I go to write my answer, I'm going to have 5 on the outside. And then on the inside, I just put whatever's left. For this one, I have m and m, which would be m squared. And then I have plus, because the plus sign right here. And then I have, for the second term, I have 3 and m. So I go 3 times m. I just multiply everything that's there, which will give me 9m. And then for this last term, I have 2 times 2 times 2. So 2 times 2 is 4, times 2 again is 8, and so I have plus 8 there. Again, if you want to check it, if you multiplied that 5 through, that should give you your answer up here again. Okay? So let's repeat that process. Let's look at that again. So if I look at this next one, I only have 2 terms here. I've got a and a. Here I have the 9, which will give me 3 and 3. And then I have the a as well. So again, I just say, what do I have in common? Here I have a's that are in common, and that's the only thing. And so when I go to write my answer, I'm going to have the a on the outside, and then on the inside I have a. And this time it's minus, because that's the sign there, and then 3 times 3, which is 9. And that'll be my greatest common factor. Okay, a couple more examples here. This one on the right here. Again, I have the 3, and then I have 2 n's for this one. This one I have 3, and I have the n, because 3 times 3 gives me 9. And then this one here, I've got 3 and 2. Again, I'm just going to see what they have in common. The greatest thing they have in common here, I've got just 3. Sometimes they have multiple things, and that you put both of them outside if they do. So that means my 3 is going to go on the outside, because that's what they all have in common, nothing else. And then I have 2 n's here, so that I write that as n squared because it's n times n. In this case, I have the 3 in the n, and this should be a subtract sign because of this middle term here. So I'm going to go 3 times n. And then my last one is this 2, so I go plus, because that's my sign there, plus 2. And that'll be my final value there. And then this bottom one, again, we're going to break this down. This one I've got 2 and 2 that makes 4. And then I have r and r that gives me r squared. And then the 24, I'm going to do my factor tree there. I've got 4 and 6, which breaks down to 2 and 2, and 2 and 3. And then I have the r as well that goes there. So again, I just look and see for things that have in common. I've got 2's that have in common. I have another 2. and I have an R as well, just one of the R's. So if you see, I've got 3 things that are going to go on the outside here. So I've got 2 times 2 times R. Well, 2 times 2 is 4, and then if I times that by R, that'll give me 4R. And then on the inside, I've got this R still left. By the way, if you take everything away, then you put a 1, but in this case, there's still this R here as well. What I mean is if I circle everything from one group, then you have to put a 1. It just doesn't just go away, okay? So we might look at one of those here in just a second. So this is just going to be R, and then plus, and then I have the 2 times the 3, which will give me 6 here. And that'll be for that one. What I'm talking about with that is, let's say I had like 3, let's say R squared, let's say plus 3 here, okay? Or let's go 3R, that's good. Okay, and so when I go to break this down, this is going to give me 3 and then R, and then this one's going to give me 3 and R. So what do they have in common? I've got a 3, I've got an R, I've got a 3, and then I've got an R. If you notice on this one, I've circled both of these. When I go to write my answer, I have to take in that account. So the 3R goes on the outside, and then as I work left to right, I have this R that still stays there, and then plus, if everything goes away, I have to put a 1 for that, because this is really just 3 times 1, so there's still a 1 there. I see way too often people just put the answer as 3R times R, which that's not correct, because if you multiply that, it's just going to give you 3R squared, which doesn't give you 3R squared plus 3. So this is not correct. You have to put that 1 there. So make sure you do that. Other than that, we should be good. Okay, it's been your math moment with Mommy. Adios.